so much. Yeah, I'm very happy to be back here in university. I also was kind of studying on these very tables a couple of years back. I see that we have currently the wrong screen on. Let me see. Ah, yeah, perfect. Thank you. All right. So today I'm going to be talking about a topic that I'm very passionate about, that I'm actually quite obsessed about. It's the topic of compute, and more specifically how mobiles play a big role. My background is in mobile security. I used to be working with some of the largest financial institutions and defense companies to basically bring in mobile devices into their setups so that they can optimize workflows and basically embrace this innovation. I do have a couple of slides, so let me jump right in. When we're looking at the demand and appetite for compute of humans, we will see two things, right? One is the hardware obviously gets better and better at an exponential scale. Here you see basically how we are printing more and more transistors into CPUs. This does not talk about the density of transistors. It's just the number of transistors in that case. And another metric that we can see as well to basically showcase this appetite is the power of supercomputers, which ultimately is measured in teraflops. You see that this is as well a logarithmic scale that shows you how year after year we're basically doubling, if not more, the amount of compute that we have at our disposal. Now, here is, however, a breaking change. With now AI, we changed a little bit the course of action. Okay, so you saw the linear line. Well, you saw the line before that was on a logarithmic scale. And that you can basically see here in the in how many data points there are being consumed by these machine learning and AI labeled things. But since a couple of years, this even accelerated quite a lot. Okay. So what does this tell us? Well, this acceleration also comes with a big centralization because a lot of this compute actually lands in centralized data centers. And as you know, there is no cloud, it's just somebody else's computer. And the big problem with this centralization is that it started off with the user's best interest in mind, offering them the best possible service, but shifted at some point to a more kind of pushing for shareholder value approach. Long story short, what it really means is that you now have a huge concentration of compute, a huge concentration of power into the hands of people that don't have your best interest in mind. And this becomes very clear now even more with AI. You saw before this acceleration of data points, which already on a logarithmic scale changed to an exponential graph. What that really means is up to a moment we had machine learning models already around since many, many years, but they were all prone to a phenomena called overfitting. So at some point, even though you were giving it more data, it would just get worse, the precision. But clearly, this is not the case with LLMs. So either we haven't reached that stage yet, so we haven't reached the moment where it's too much data, or LLMs are simply not prone to that, right? And if you now think about yourself as an individual, this means that all of these big hyperscalers are super hungry for data because they're able to extract more and more value. So up to this moment, it was not so relevant that you were sharing a lot of data with them because they couldn't really process or extract value out of them, and now they sure can for all sorts of use cases that may also go against you. One of the things that make this very, very visible is that if you have access to these big models that are centralized, you're basically able to influence the perception of the general public. In this specific case, we see how Google, being a company that is pushing a lot for diversification and diversity, ended up creating a model that would reflect those values in their answers, right? And here, basically, and actually then returning incorrect data, because as you know, the chances of female or black or Asian soldiers on the German side in World War II are very, very slim, right? But it's not only Google. With DeepSeek, this becomes also very clear. Here, asking a critical question that the CCP is not interested in sharing, you see how basically the model itself, even though it has all of the knowledge, because you see the thinking process. I don't know if I can. You see the thinking process. We're asking about this iconic picture of a man holding bags in front of this line of tanks, right? The model starts answering the thing correctly, but the minute the Tiananmen or Tiananmen Square keyword shows up, it's being censored. So a lot of power is in this compute and in this AI, because it can shape the way we perceive and basically act in the digital world. Long story short, you need to take control back into your hands. And what we really need is a decentralized system that puts you basically first. Now, decentralized systems are not immune to enshittification that I described before, which is the process of moving from something that had value to basically shifting the alignment to something else. But if you're able to come up with something that is truly global scale and decentralized by the people for the people, you're able to offer an alternative that actually has, again, your best interest in mind. This is nothing new. During the ICO times, this narrative has been handed out a couple of times. Already today, there's a couple of tokens that are trading actively in the space of decentralized compute. But all of these tokens and all of these projects are basically missing one big point. And that point is, why would you rely on centralized data centers when you're trying to build a decentralized compute network? Because if you do, if you basically just use the same old tools and wrap them with a new wrapping, you end up with a system that we have today, which is this pseudo-decentralization where people say we have thousands or even millions of nodes. Meanwhile, those nodes actually live on the AWS cloud, right? Or also the problem that a lot of these networks are basically just working with self-reporting, where people just say, yeah, I do have that hardware, trust me, which obviously in an adversarial space such as blockchain never works, because people will take advantage of that, and they actually already took advantage of that. And last but not least, all of these systems require trust in whoever is providing you with the computing infrastructure, which obviously is a problem, because if they can tamper with your execution or can tamper with the data you share with them, this will never take off, this will never reach mass adoption. And now we come to my obsession, because basically we don't have to look that far for the answer, and the answer lies in your pocket. everybody has a mobile device. If you remember the short and brief chart that I had before, when it comes to compute, these chips actually lead the way. You see here many mobile chips as being the ones chosen to prove this Moore's law. If you now would even start dividing the number of transistors by the actual area that you have, you will see that mobile chips already are working on 3 nanometer technologies, way more efficient than servers, and are basically already out there, the way more modern hardware. Now I will quickly try to bring my passion and obsession for mobile devices to you with a couple of examples and why I believe this really matters. So one thing is that mobile devices are secure by design. And the reason is mobile devices don't have the privilege to have physical security like a server in a data center. In a data center, you don't have bad actors physically accessing your hardware. With mobile devices, you cannot rule out this attack vector. This means that if some of you now needs to go to the bathroom and leaves a phone here on the table, somebody else could just pick up that phone. Now, why would you leave your phone here on the table and go to the bathroom? Well, because you know that that device is actually secure, right? You're using it for all of the mobile banking, managing your wallets, managing your identity, and so on and so forth. A lot of effort has been put into creating the most advanced hardware security modules out there that offer both verifiable and confidential compute, and we'll see why this is important in a bit. The other aspect is that mobile devices are the most decentralized form of compute out there. Already today we have 8 billion humans and more than 7 billion mobile smartphones actually in circulation. So the vast majority of compute is actually in mobile devices. We sell 13 million mobile devices annually, while we sell as well 1.2 billion servers annually, while we sell 1.2 billion new phones each and every year. What you have to add on top of this is that the lifespan of a server is usually 10 years, while a mobile device is about 2.5 years. That means that you have also Moore's law working in your favor in this case. But it does not end there. So you have Apple that basically invests the entire market capitalization of all of these compute coins each and every year in just R&D. The iPhone is big business. The iPhone alone makes up for more than 60% of Apple's entire revenue. So it's clear that this is also not only one of the most secure, scalable, and decentralized devices, but also one of the devices where a lot of R&D money is actually being poured in. So who would have guessed? This is basically the project Accurist that we're building upon these core values and these ideas, which is a real decentralized compute network that allows you to onboard mobile devices. How that looks like, we can see here with one of our users who onboarded about 200 devices. All of these devices are interconnected with USB 3.2, so they have a 40 gigabit interconnection, offer 8 cores, 8 gigabytes of RAM, and what you can see here at the end is actually the killer use case, which is you're able to load or upcycle devices that are broken. You are able also to tap into a vast community already today. So if you have a mobile device, a spare phone or something like that, you're welcome to actually onboard them. And even though it's just on testnet, this concept has already been battle tested at scale. And we already have quite a distribution. It's not perfect yet. I think we still have a lot of work to do on the Africa side of things. Now, looking at time, I see that my time is almost up. That's why for whoever wants to see the demo that I prepared, I'm very happy to do this right after the call. But basically everything is completely permissionless, and it's not that you get slapped in the face with a contact us form whenever you try to deploy something. Use cases for the developers in here is you can think of it as a general compute platform. So you interact with it using just WASM workloads or Node.js workloads. And the best use cases are actually the ones that rely on these three main USPs that the platform offers you. Concrete use cases actually lie in the verifiable secure on-chain automation, as well as then web scraping and distributed simulations, because yeah, you just have a lot of compute out there already on the network with more than 100,000 high-performance cores. So that's it from my side. I would love to talk longer about all of these topics. And as I said, if you want to see a demo, I'll gladly show you outside. Yes, if you have a spare smartphone or you want to onboard your everyday device, please do so. The mobile apps are already in the stores for you to grab, or even on GitHub. Thank you so much.
Thank you, Alessandro. Are there any questions from the room? 3, 2, 1. Okay. Thank you very much.
Thank you.